Hello everyone, welcome to my YouTube channel. Today I'm going to talk about the quicksort algorithm. For the Leetcode question 912 sort an array, the quicksort solution was an accepted solution in 2022. So my previously submitted solution in 2022 was accepted. However, I believe after the recent change, it becomes a time limit exceeds solution. But I still want to cover this solution just in order to go over the quicksort algorithm. The reason why it went out of time limit is because of the time complexity. The quicksort has an average and best time complexity of O(n) log n. However, the worst case time complexity is quadratic O(n) to the power of 2. And then this problem statement is you must solve the problem in O(n) log n time complexity, so it will fail some of the test cases. So let's take a look at the quicksort algorithm. The basic idea is very similar to the merge sort. It's still divide and conquer. Divide, it means you choose an element in the array as a pivot, and then you just compare the elements with this pivot value. You put the elements that is less than the pivot value to the left of the pivot, and then the elements greater than this pivot value to the right of this pivot. And then you recursively sort separates to the left and the right of the pivot. So in the end, you will have a sorted array. So compared with the merge sort, the benefits of this one is you do not have to use an actual space to store the outputs. So that's why the space complexity is O(1). However, the time complexity, unlike the merge sort, it has the average case and the worst case equals to O(n) log n. Quicksort has a worst case quadratic time complexity. So let's start code the quicksort algorithm. We define the quicksort. Basically, we want to start with the head position and tail position. So basically, those head and tail are two variables points to the start and then the end of this array that we are currently sorting. So the base case, if this head position is greater than or equal to the tail position, which means either this array is empty or this array has one element in that. So in that case, we do not have to perform any operation to sort it, so we can just return. Else, in that case, let's use two pointers. I call it left and right. Basically, initially, it points to the start and then end index of this array. And then I use a pivot. So basically, when we select a pivot, there are different ways of choosing that. So my preference is always choose the midpoint. So that is L plus left plus right divided by 2, integer divide. And then so that I can get a pivot value. So basically, this step gets the pivot value. And then after that, I need to start my comparison. So basically, I need to make sure that, okay, while comparing it, my left pointer is less than or equal to my right pointer. And then I check, let's say, first step, we want to make sure all the numbers. We check if we use the left pointer to check for the elements less than the pivot value. Okay, if the left pointer L points to the element that is less than pivot value, then we just increase the L to point to the next value. It will stop until we reach a position or reach an element that is not less than the pivot value. So that's when the left pointer stops. We're doing the similar thing to the right pointer. So basically, right pointer start from the end of this array. It compares every element with the pivot value. If the element it's pointing to is actually greater than the pivot value, which means that's what we desired. So in that case, we just reduce the value of the right pointer by 1 to point to the next position. So basically, the left pointer and the right pointer. Left pointer is moving from left to the right of this array. And then right pointer is moving from the right to the left of this array. They are continuing moving. If let's say we want to put the elements that is less than pivot to the left and the elements greater than the pivot to the right. So while this condition is satisfied, in that case, we just keep moving our left and right pointer. And we point the pointer if the condition does not meet. Let's say we may pause our pointer when the condition does not meet. And then after we jump off of those two while loop, then in that case, if the L pointer is pointed to the position that's still less than or equal to the position the right pointer is pointing to, which means we are comparing the index when they stopped. So in that case, we just swap the value. Why we swap the value? Because, okay, so now the while loop condition, the inner while loop condition on the line 31 or on line 33, they do not meet each other. So in that case, which means, okay, my on pointer, my left pointer is stopped at position that is greater than pivot. So we want to put it to the right instead of the left. And then right pointer stop at position that is less than the pivot value, less than or equal to the pivot value. We want to put that one to the left of the pivot instead of the right. So what we can do right now is we can actually swap those two elements that are in the wrong location. After swap, we make sure that we meet this condition. We put elements less than pivot to the left and then greater than pivot to the right. After swap, let's do the updates. After swap, we update the index of the left pointer and then the position of the right pointer. Because after swap, we already meet the condition. And then now we just need to consider the next element. So in the end, after this outer while loop, we finish this path. That means, okay, we put all the elements less than pivot to the left and then greater than pivot to the right. Okay, so in that case, we can start considering the subarray. So in that case, we call the quicksort again. In this case, the two subarray are so we call the quicksort, and then for the subarrays, the two subarrays are the first one start at index head, ends at index right, and then the second subarray start at index left, ends at index tail. So why is the index arranged this way? So that's remember. So when you jump out of this while loop in line 30, in that case, the L and R, left and the right pointer, they already cross. So in that case, we just need to consider sort the subarrays to the left and the right of the pivot. So this is our quicksort code, and then in order to sort the array, we just need to call this quicksort for the starting index, that is the 0, and then the end index for this nums array. So let's run some initial test cases. Okay, so it passed the initial test cases. However, this is not an acceptable solution because it will run into the error time limit exceeds. That is because the worst case scenario, the time complexity is quadratic. This problem has a requirement that functions solve the problem within the O(n) log n time complexity. But I still went over the quicksort algorithm as it's a very important algorithm and it's used a lot in reality as well. So let's recap the basic idea for this algorithm. So basically for quicksort, we are given the start and end index of an array. And then first we consider the base case, that is when the array contains less than or equal to one element, which means it's either empty or it has one element. In that case, we do not need to perform any sort. And then after that, we begin the sort. If that's not the case, we begin the sort. We use two pointers, left pointer and right pointer. Initially, they point to the start and the end of this array, and then we determine the pivot value. There are multiple ways to determine the pivot value. Here, we just choose the midpoint of this array as a pivot value. You can choose the leftmost index, the rightmost index, or just call some like random value generator to point to a random position. Here I just use the midpoint, and then I get the pivot value. And then I start doing my divide and conquer. Basically, after choosing an element, I'm trying to put elements less than pivot to the left, and then elements greater than the pivot to the right. That's what this while loop does. So basically, while all the elements to the left is less than pivot, we just keep increasing our left pointer, move it to the next elements. While the numbers to the right is actually greater than the pivot. In that case, we just move our right pointer to point to the next element, which means we are moving the right pointer to the left. And then if we stop at position, let's say when we did not actually cross the left and the right pointer, but we stop at a position because the values does not meet our condition. So we have a misplaced pair. So in that case, we just swap the elements to make sure this condition satisfies after the swap. And then after that, we just update the left and the right pointer to consider the next elements. So after we finish this step, we just keep repeating this process for the subarrays. That is the overview for the entire quicksort algorithm.